Welcome to another episode of my construction videos. What I do on this channel is to make videos on construction. I create construction content for people that might want to need it, probably for people on site who are doing the major work of construction. For all the personnel on site, the architect, the engineer, the quantity surveyors, and as many people that need it, including client and laymen who want to know some things about construction. That is who my video are for. I create construction content. Now into this video I'll be taking us on how to read a structural drawing. In my last video I made a video on how to read an architectural drawing, so I was able to take you through the way you can read an architectural drawing. In today's video I'll be showing you how to read a structural drawing. For as many people out there who want to how to read a structural drawing, this video is for you. Now, what is a structural drawing? A structural drawing is a drawing that is made by a structural engineer. A structural drawing actually deals with how the structure is going to stand. You know, in my last video, I said I did something on architectural drawing. So the architectural drawing will give you the aesthetics of the building, how it's going to look like, what the building is going to contain. Now, the structural drawing, the structural engineer will get the architectural drawing, and from the architectural drawing is going to produce a structural drawing, that is how the building is going to stand. I created this with the aesthetics of the building, but the structural engineer is going to tell you how the building is going to stand, the size of the column, the reinforcement in the column, the size of the beams, the reinforcement in the beam, the foundation type, and every other thing that has to do with how the building is going to be stable, the stability of the structure. At the end of this video, if you find it interesting, you can give me a like and subscribe to my channel. So join me in the video and let's begin. Now, just like the architectural drawing, the first page you see on a structural drawing is the front page, which will tell you the title of the project, the title of the drawing, the location, and the owner of the project. The next page will have a general note on construction. You are going to get some general note on what you have to do and what the contractor is likely to meet in the drawing, and some general note. Then let's move to the next page. Yeah, on the first page, what you see is the from a social drawing is the type of foundation here. It's just a general layout on the foundation, because on the structural work, on any building work, you start from the foundation. So the first thing you see from the structural drawing is the type of the foundation layer. If it is a pipe foundation, you see something that is related to pipe cap and pipe. But here we are having the raft. We are using a raft foundation, so you have the compartment you are going to have in the raft foundation, and the names of the beams, the names on the beams, the position of the columns. This is C1. This C1 is telling me that the type of column here is the type of column you have on that point. C2 means this is a different type of column on this surface. So that's how to know the type of color. You are going to find that all those on the raft foundation layer. Now let's go to the on the foundation layer rather. We are going to find all those details on the foundation layout. Now the next aspect is the beam. If you are building a raft foundation, you have to build the beam and then the slab on it. So here is telling you the names of your beams and the title of your beam, the reinforcement is going to contain. Now let me go back to one of the beam and pick one. I'll pick one of it, then I'll explain it. Let me take it by the axis. This is, let me assume I want to take this beam here. This is D. This is the grid line D, then 2 to 3. This beam is grid line D, 2 to 3. Now let me go to that. It is grid line D2 to 3. Let me confirm that again. D2 to 3. So you look for D from this area. Okay, this is what we are looking for. So let me just drag to this area. Now this is what we are looking for. You can see, zoom it a little bit. This is D2 to 3. So this is telling me that three 16 mm at the top. This 3T16 is telling me you have 3 16 mm at the top. At the bottom, you have 2T16, meaning you have 2 16 mm at the bottom. This is 2 multiplied by 3T12. It's telling you that you have 6 runners, that's 3 on this side and 3 on the other side of the beam. Then this value inside is telling you 24 wide 10, meaning you have 24 rings that is made up of 10 mm. It is made with 10 mm reinforcement rather, as you have 24 rings here on this beam. So that is how to read that. It's as simple as that. So you can pick any other beam and look at the section. So this is Raft beam detail, the elevation and the section of the beams. You can pick anyone from this area. You come to this area. That's how you read the reinforcement. You look for the grid line. This is grid line G, and this is 4 to 6. But if I want to check the reinforcement on this aspect, this is grid line G, 4 to 6. So I will go back to grid line G. I will look for the one that have grid line G. Okay, this is it here. Let me zoom in. And okay, this is the line G. A and G are the same thing. So A and G have the same force, so it has been grouped together. A and G. Then what I'm interested in is 4 to 6. So this is 4 to 6. If you can look at it, you can check it, but this is 4 to 6. So is a continuous beam. So you cannot just get the reinforcement are together. It is a continuous beam. That is what I deducted from that. So the whole of the beam will be taken as one unit because it's a continuous beam, not simply supported, just like the one we just checked now. Now, let me go to the next page. Let me zoom out. So, the next page is telling me about the ground floor slab. So ground floor slab, everything has been detailed, and you have your reinforcement here. So when you design, all these values, they will be inside this section here, this slab here. But because you need to detail and present your drawing in a better way, in a good manner, that the user of the drawing will find it very easy to use. Now, if you look at this, you have one on this reinforcement. That is a sign of reinforcement covering this area, and this is the dimension. Let me zoom in a little bit. Now you have this dimension. This is telling you that this is the reinforcement, and this is the area the reinforcement is covering. This blue line is showing you the area the reinforcement is covering, and this is the reinforcement. So how do you know the detail of this reinforcement? You come to this area here. This is the bar mark, which is 1. So this is 23 Y12, bar mark 1 at 225 spacing, which will be at the top. So it means you are going to have 23 12 mm on this. As I said, they are going to run like this, vertically like this, 23 length of 12 mm. So if you want to get the distance, you just add up all this together plus the crank. The crank is always 1/4 of the length of this span. 1/4 by the length of this one. You are going to get this crank and this crank. So let me pick another one at random. Let me say I want to use 18 bar mark 18. Now you come to this side here. 18 is 17 Y12 at 225 spacing, which will be at the top. So it means this area you're going to have 17 12 mm reinforcement. You're going to have it at this area. Now if you want to get this crank, it is 1/4 multiplied by this span here. So that's how to read structural drawing on this aspect. Let me zoom in again and go to the next one. Now the next one here, after the slab, you have the first floor slab. Now just like the details I told you in the previous one, everything still applies here. You're having your staircase in this region. You're also having your staircase in this region. So everything applies here. So after the GA, we call this GA, general arrangement. After it's just like a layout of the floor plan. Now after the general arrangement, you have the beam details, just like I explained from the previous one. Everything still applies here. Now after that, you have the slab detail. The slab detail, just like I explained in the ground floor details, everything still applies here. Then you have the second floor, because this is a two-story building. You have the second floor general arrangement, which I say is like the layout. Second floor general arrangement, everything I said in the ground floor still applies there. So this layout, okay, let me just explain this. Let me zoom in. Let me zoom in a little bit. Now, what you have here, you are having this direction here. Now, what this direction is telling you that this is a two-way slab. The software designed this as a two-way slab. How do you know it is two-way slab? Your ly over ls, that is the longer span over the length of the shorter span. If it is less than 2, if it is less than 2, it will be designed as a two-way slab. If it is less than 1, it is designed as a one-way slab. Now, this is telling that it is a two-way slab. The height here is telling that the height of the slab is 150 mm. That's the depth of the slab. Now, let me use this panel. If I use this panel here, it's telling me that this is designed as a one-way slab. How do I know it is one-way slab? The longer length divided by the shorter length, the length of the shorter length. If it is greater than 2, if it is equal to or greater than 2, you are going to design as a one-way slab, and this is a sign that this area is a one-way slab. Every other thing I explained from the ground floor still applies here. So every other thing still applies there. The beam, if I want to check it's okay, this is the general arrangement, just like I said. So I want to check maybe any of the reinforcement. Let me just pick this in the middle. So I will just look for the grid line. The grid line is D, then 2 to 3. So I can just go to the next page. So I will look for the grid line that is D, 2 to 3, which is this one. So if I zoom in, this is D2 to 3. The size of the beam is 230 by 450. And I have 3 reinforcement at the top and 3 at the bottom. There is no runner because the beam is 4, the depth is 450, it is small. So you don't need a runner. 3 at the top, 3 at the bottom. That is how to read structural drawing. That's how to read the beam elevation and the section. Now let me go to the next one, which is this is the slab detail, the second floor. This is the slab detail. Most of the times, the first floor, the suspended floor details are always similar. The phenomenon is that the slab is taking the load from irrespective of the floor it is. It is taking, let's say we are on the 5th floor now. The slab on the 5th floor is taking the load. It will transfer the load to the beam, then the beam will transfer it to the column. The next floor will still take normal. It is not that the load from the other slab will add to the one at the 4th floor. No, the 4th floor slab is taking its own load, transferring it to the beam, which will still be on the column. So the column is taking more of the load. The beam are taking their own load, not the load of the slab rather. Is taking its own load, the load on it, the live load and the dead load on it, and it's sending to the beam, which is sending to the column. And this is the roof beam layout. The roof beam layout, just like the one I said, the roof beam layout, just like the general arrangement of the beam. So you have it here. When you see this cross is telling you that there is no slab on this area. So this is a water tank area, and this is a roof gutter at the back here. So this cross is telling me that there is no slab on it. So anywhere you didn't see this cross, meaning there's a slab on it. That's how to read and a structural drawing. So I still have the beam layout, the beam elevation and section, just like before. Now this is giving me the detail of the slab. There is a water tank groove gutter here. I will have the detail, and there's a water tank slab here. I have the detail. So the details are like just like before. You just come to this bottom here and pick. Then you get the length, the numbers of reinforcement you need. So now this is the column detail. So let me zoom in. The column detail most of the time is always at the back of the drawing, like 2 or 3 page to the back of to the last page of the drawing. That's where you always find your colon details. Some engineer will put it in the front. Most of the time you find it at the back at 2 or 3 page to the end of the drawing. That's where you find it. And this is a typical colon. This is colon C1, which is 225 by 225. This is C2 and this C3. The type of the colon always change depending on the reinforcement in it and the size it has. So it always has different shape and the reinforcement. So the type of reinforcement in it will trigger the change in the colon. Okay. Also on this, you have the staircase. So now this is the roof gutter later. I told you about there is a roof gutter on the roof beam. So this is the roof gutter. This is the details of it. And the staircase also, you have the detail of the staircase at the back of the drawing. And this is another staircase detail. So that is all on how to read structural drawing. Though I know I skip some things because if you want to understand the structural drawing, you need to have experienced how the construction is being done. As if you are just reading the drawing, some of the time you don't understand until you see how these things have been done on site. That's when you know, or you are conversant with a lot of drawing. That's when you know how all this drawing, or how all these things are being done on site. So that's the end of the video. If you find this video interesting, and give me a like and subscribe to this channel. And if you have any comment, kindly put it in the comment section and I will respond. Thanks for watching.